presentation is organized by the Living Future Collaborative South Africa, and my name is Marloes Reining, and I'll be your facilitator today. I am joined with my co-hosts Tulani, Denise, and Audrey, who are the core of the collaborative. So we are very happy and very grateful that we have a sponsor, which is EcoSmart, and you can see the website there. Visit the website. It's a company based in Cape Town, and they provide cost-effective renewable energy solutions. They are fully committed to making our world green, and they have renewable energy solutions for domestic, commercial, and industrial customers. I've learned about them since they wanted to sponsor us, and I've been browsing their website, and it looks super interesting. They have a really cool, innovative hot water generation system with pellets. So check them out. I'm sure every one of you will find it interesting. So thank you very much to EcoSmart for sponsoring this event. This webinar is brought to you by the Living Future Collaborative South Africa, and we are part of the Living Network, which is organized by the International Living Future Institute. I'm going to let the first speaker talk about the International Living Future Institute, and I want to just briefly talk about the Living Future Network. We have set up a Living Future Collaborative in South Africa, which is a group of like-minded people who want to bring the vision of the Living Future Institute to South Africa and spread the word. If you want to join the collaborative, you're more than welcome. I'll give you an email address where you can drop us a line, and everyone is welcome to join the collaborative. We have presenters in South Africa, which is Tulani and me, and if you want a presentation, an introduction into the Living Building Challenge, please contact us, and we are happy to come and deliver a presentation to you. And then a little bit about Living Building Challenge in South Africa. Those of you that have gone through an introduction of the Living Future or the Living Building Challenge know that it is quite a challenge. However, we do have projects registered in South Africa, and that's super exciting. So there are people brave enough to take up the challenge and go for it. There's 2 residential projects in Cape Town, Glencoe Road and Rugby Road, which are both registered for full Living Building Challenge. There's a project in Johannesburg, 76 Corler Drive, which is registered for petal certification. And there's the Green School in Paarl, which is full Living Building registered. And Fabio from Terramancy, there you go. Fabio is the green consultant there. And Solid Green offices in Joburg are also registered for core certification. So there's some exciting things happening. And Chilu will dive into some of the case studies, some of these projects as well. But today, it's not my presentation. It is going to be Haley, Francois, and Chilu's presentation. And I'm going to quickly introduce them to you. So the first speaker will be Haley Gardner. And Haley works for the International Living Future Institute, where she supports the zero energy and the zero carbon certification programs. She provides technical guidance on how buildings can achieve net positive carbon on a whole building life cycle assessment, while at the same time maximize on their energy efficiency. Civil engineer by training, and when she is not daydreaming about green buildings, she is playing soccer. Then we have Francois Retief. Francois is for his company Sow and Reap, a sustainability consultancy for the built environment. He has worked previously for the Green Building Council, where he was in charge of developing and operating a number of green building rating tools. He has a keen interest in building energy and water performance, and is very eager to make a difference in optimizing performance of existing buildings. He is a mechanical engineer by training, and when he is not daydreaming about net zero buildings, he's probably building his new home, obviously a sustainable one, in Hout Bay. Today, he's speaking in his capacity as a sustainability chair for the ASHRAE chapter South Africa. And then our last speaker is Chilufya Lombe. Chilufya is my business partner at Solid Green Consulting, also a sustainability consultant for the built environment. And Chilufya is probably one of the most experienced energy simulation and modeler in South Africa, and has been using that skill to up the energy efficiency of many green building projects in South Africa. He is also a mechanical engineer by training, and when he is not daydreaming about net positive buildings, he generates WhatsApp groups and attempts to build his new house and our new offices as sustainable as possible. So with this, I'm going to hand over to the first speaker, Haley Gardner. Haley, please take it away.
Excellent. Good afternoon, everybody. I'm calling in from the Pacific Northwest of the United States, so it's still actually a dark morning over here, but I hope you all have had a great day, and thanks so much for joining and for having me. So I'm just going to give a brief introduction to the International Living Future Institute. As I said in my introduction, I work at ILFI and I'm the manager of buildings and energy here. And so I work on zero energy, zero carbon, along with the energy pedal within Living Building Challenge. So you're here, which means you know that we exist. You're aware of the collaborative. You've probably heard of Living Building Challenge, but we have a number of other programs and rating systems and transparency labels that we work on at the Institute. But again, today we're going to be focusing on the Living Building Challenge, zero carbon, and zero energy. So I'm just going to set the stage for the requirements and kind of the bars that we set and the targets and to help people meet those high efficiency targets. As was mentioned, also the mission at the Institute is to catalyze transformation towards communities that are socially just, culturally rich, and ecologically restorative. And so I feel like all of these three things should be prioritized in every building project, every building related project. You know, we work with communities and products, and this is really our guiding principle. And so we really see this philosophy as a tool that project teams can use, that our certifications really support the progress towards this living future. So like was mentioned, it is a challenge. All of our programs are not meant to be easy because we're on a pretty strict timeline for a lot of these, you know, climate change solutions. And so they're not meant to be, you know, just kind of doing what's okay and moving forward. So we really want these to be a driving force towards that progress. And so we see our programs as not just being kind of that center point, that sustainable zero point, but net positive, like this event, which is very timely. And so Living Building Challenge sets those really high positive environmental impacts because we want these projects to be, again, not only net zero or sustainable, but actually regenerative and having an overall extremely positive impact across the board, you know, not just for energy, but for other elements that I'll briefly touch on. So today, like I mentioned, we're going to be focusing on LBC, zero energy, and zero carbon. Know what we've set in those requirements and why. And then I'm really excited to hear about the other presenters today and hear about some case study projects and some more practical applications of these. Last May of 2019, we released Living Building Challenge 4.0, and then this last spring, we released the pedal handbooks, which are the guidance documents that go along with 4.0 and have more details about how project teams should be achieving these requirements that we set. Within LBC, there are 7 petals. We're really big on metaphors. Our favorite one is a flower, so you're going to see a lot of flowers today. And within LBC, there's 7 petals within a flower, because the idea being that a flower only uses what it needs to from its environment and also provides something back. So it's a very symbiotic relationship. That's how we see every building project should be. So there are 7 petals here: place, water, energy, health and happiness, materials, equity, and beauty. And while all of those have tremendous value for widely different reasons, today we're going to be focusing on energy. Just wanted to touch on the requirements here. The way that LBC works is that within those 7 petals, there are a total of 20 imperatives. So you have to achieve all 20 imperatives to be full living. And then a new program that we released last year as well is called CORE, which you can see the logo here above the number 7. So CORE is basically half of LBC. Not to say that it's 50% of the effort, it's still challenging, but CORE really focuses on a really high performance building that we think all buildings should be designed to, should they have, you know, because the Living Building Challenge is, again, it's a challenge. It's called that for a reason. So CORE kind of gives teams a spot in the market between some other rating systems and living building, because we recognize that there's a pretty big gap between that and the challenge. So anyways, within the energy pedal, there are 2 imperatives the project teams need to meet. So the first being this energy carbon reduction. So again, this is prioritizing efficiency. There's an energy efficiency target teams need to reach based on their typology. So if it's a new, existing, or interiors project, there's no permitted use of combustion in new buildings. There's some some exceptions about existing projects or interior fit outs where project teams might not have as much control over the base building systems, but we at the Institute are very big on eradicating combustion from buildings because, again, that's a really big part about decarbonizing our building sector and reducing those impacts. Then there's a reduction to the embodied carbon of primary materials. So embodied carbon being all the energy required to manufacture a product and then construct a building. So primary materials being your heavy structural materials, so your structure, enclosure, and foundation. So this is basically going to be concrete and steel. And so that reduction is a big focus of a lot of teams right now, actually. And then also we encourage teams to select less impactful interior materials. So those would be things like wall boards, flooring, that kind of stuff that isn't, doesn't have an impact on the structural elements of the building, but still are used in mass quantities within a typical building. And so there's also a lot of data being developed around those interior materials right now. So now it's kind of just like preliminary, look at what you can do that's better. And then since this is the first imperative, there's a requirement for teams to be zero ready designed, which means they're installing pre-wiring for things like future PV, future renewables, or any electrical vehicle charging they might be able to have in the future. And then the second imperative is where that net positive comes into play. So within LBC, like I mentioned, we don't go for the net zero, we go for net positive. So teams have to supply 105% of their project's energy demand on site with renewable energy. So again, being the flower, operating within your site, using the energy that you can generate there. Teams are required to submeter so that they can understand their end uses and troubleshoot really quickly and easily. And this really helps other teams and lessons learned for those teams. Another big thing about this imperative is that teams need to account for and offset their project's total embodied carbon. So that's going to be the impacts of your primary and interior materials. And in our guidance, we have a list of tools and softwares that teams can use to calculate that. There's a lot of work happening in that space. So if you're interested in anything carbon, let me know, because it is what I spend 90% of my time thinking about. And then lastly, within LBC, something that we're really excited about for 4.0 is that teams, we've kind of evolved our resiliency approach. Before it used to be strictly battery backup, but as we talked with teams, because our programs are based on project team feedback, we don't want to be setting requirements that don't make sense in practice. And so we've been talking with teams, and the battery backup only wasn't necessarily the best option. So instead, now teams can develop a resiliency strategy to allow the building to be habitable for 1 week. So that likely involves some type of energy backup, but it also could be, things like emergency kits or phone charging, or, things like solar phone charging, things like that support the building's habitability. So now to move on to zero carbon. These go quick. So similar to the energy pedal, zero carbon looks at both operational and embodied carbon, operational carbon being the impacts associated with your building's energy use, and again, embodied being everything that goes into making those materials. Next slide. So similarly, again, to LBC, there's a reduction required to those heavy primary materials, to operational carbon. There's an energy efficiency target also required without the use of new combustion, but there are more pathways for existing buildings to use combustion for zero carbon. And then offsetting, you'll note 100% of energy use with either installed renewable energy, so either on or off site. That's a little bit different than LBC as well, because you can look beyond the site of your flower. And then on the embodied side, very similar, reduction in those heavy structural materials. You have to tell us what the total carbon intensity of your project is. So that is a kilograms of CO2 per square meter of your project, because that's a really important metric that we're using to study the impacts of different building types in programming. And then offsetting that with either carbon sequestering materials and or purchasing carbon offsets. Lastly, we have our zero energy program. And this one is very simple. The only requirement here is that you need to be zero energy. We created a really streamlined program for teams that just wanted to show, not just, but who wanted to show that their site energy consumption is equivalent to their on-site renewable generation. So this is also the 100% pathway. So there's no extra buffer there like there is with LBC. And again, without the use of combustion. We're pretty strict with zero energy teams not using combustion, because again, that's a really important part about showing that you can operate fully off of renewable energy. programs interact with each other, overlaps, is that we saw with net zero, LBC is very net positive, so goes above and beyond that net zero. And so within net zero, zero carbon, you have a little bit more flexibility about being, again, on or off site. Combustion, LBC and zero energy, pretty strict, but some pathways within zero carbon. And then for embodied carbon, there's nothing about it in zero energy, but LBC and zero carbon are pretty strict, or pretty inclusive about that. So now I'm just going to wrap up with a couple of case studies that we really like to share. So unfortunately, the two projects I'm talking about today are in the United States, which means that I need more people like you to do really awesome things in South Africa so that I can talk about them and have more interesting international projects to talk about. But these are both really cool. I promise they won't disappoint. So the first project is called Catalyst, and this is a project that's located a little bit east of where I am right now in Eastern Washington. This project is institutional, so it's associated with a few universities that are in the area. And from an operational carbon side, they're actually on a zero emissions district energy system. So they are basically on a fully clean grid that they contribute renewable energy to. And they have some on-site energy on their roof of the project, and then they're also procuring or installing additional off-site solar very near to their site. And then from an embodied carbon perspective, it's a cross-laminated timber building, which is becoming all the rage in North America. There's a lot of CLT projects happening because we're starting to look really intensely about the impacts of wood and figure out, not all wood is good wood, but figuring out how to use that as a carbon sink within buildings. So they use CLT. They also procured this wood from a local manufacturer, so they really had good interaction with their supply chain and really understood the impacts of the products they were using. So if you're interested in this and learning more, a big academic research body we work a lot with is the Carbon Leadership Forum, based out of the University of Washington. They partnered with Katerra, who's the lumber supplier, and they did a full life cycle assessment of this Catalyst building. So that's available on CLF's website if you're interested in learning more. And then the next case study is called 303 Battery, and this is a multifamily residential project, also here in Washington, about 2 miles, 4 kilometers from where I am currently. So it's right outside of downtown Seattle. This project is really cool for a lot of reasons. They're pursuing Living Building Challenge Energy Pedal, along with zero carbon on a volume scale, which means that they're looking across their portfolio to understand how they can apply these design strategies and set themselves up for certification across a number of different projects. So Sustainable Living Innovations are the masterminds behind this, and this project is extremely energy efficient. And you can also see here from the mock-up that 3 of their 5 walls available have solar panels covering them. So they have 2 on the facades, on the balconies, and then their rooftop solar array. And they also did a ton of energy modeling and really looked at zones and how to be most efficient to be net positive, since again, they're pursuing the energy pedal on site. And from an embodied carbon perspective, when SLI was created out of another architecture firm in the United States, they asked themselves, how can we build a building that is you can construct faster and cheaper, which I feel everyone has probably asked themselves before. And their answer was panelized construction. So they assemble all of these things offsite in a warehouse and then transport, the blocks basically on site and then construct it in much shorter amount of time, which obviously reduces construction time and waste because it's in a controlled environment. So they don't have they design everything very meticulously to what they need. This also results, in a much lighter project again. It's about 80% lighter than an equivalent building of its typology, which is really crazy to think about, all of that material that they're not using because of their efficient design and innovative thinking to this. And they also own or participate in every part of their supply chain, which means that, yes, they have this, they've achieved these really impressive reductions from this different design, but they can also iteratively go back and look at every step of their design of their supply chain and reduce the impacts from there as they progress. They have a lot of projects in the pipeline, so check out their website if any of those seem cool to you and you want to learn more. And any case studies that have been certified, so these are both projects, the two that I talked about today are pursuing certification. So any of the ones that have been published and have gone through a year of a performance period, since we're outcome-based, are posted on our website there. We have a lot of zero energy case studies available for you to explore there. And then, like I mentioned, we have our LBC 4.0 standard available, and then our pedal handbooks that we just released and updated a couple weeks ago, which is very exciting. I'm most excited personally because I got to work on this, is we just released our zero carbon handbook a couple of weeks ago. So this gives project teams in-depth guidance about how to meet those requirements that we talked about today for zero carbon. And there's a lot of buzz happening with ZC that we're working with right now. Again, it's what I spend most of my time on. And so we're really excited to get that resource out for teams. The standard is available on our website, and then the handbook is available for members through their dashboard. With that being said, thank you so much for your time. I really appreciate it. And I look forward to, again, hearing from the other speakers and for our discussion later today. So thanks so much.
Thank you, Haley. That was a really great overview of what all the ILFI programs regarding net zero. So I'm going to hand over to Francois to tell us a little bit more about getting to zero in South Africa.
Thanks, Marlies. Thanks, Haley. Great, thanks. Yeah, so getting to zero. I know positive sounds a lot better than zero, but getting to zero is a journey that ASHRAE South Africa chapter has walked along with a couple of partners that I'll chat about in a minute, and have produced a guideline, a short guideline, summarizing the work of others in the industry. A quick overview, I'll chat through ASHRAE South Africa chapter for those who don't know us, a little bit about the C40 buildings program, because I think that's quite exciting and not all of us know about it. And then take you through some of the highlights out of that Getting to Zero guideline document that I mentioned. ASHRAE South Africa chapter. So ASHRAE, for those who don't know, American Society of Heating, Refrigeration, Air Conditioning Engineers. So you might say, why American? Well, ASHRAE was founded in America in 1895, but it's now a global organization with about 5,700 members, about 130 countries. And really, it's a nonprofit organization that aims to advance heating, refrigeration, and air conditioning design. And they play a pivotal role in sharing cutting edge knowledge and research in the sphere of heating, refrigeration, and air conditioning. So our local South African chapter is what I represent. So I chair the Sustainability Committee, and working on this net zero energy guideline has been myself, Yogesh from PJC Consulting, one of our members, and Lombe, who you'll hear from in a bit, also one of the member companies of ASHRAE SA chapter, Solid Green Consulting. So the work we do aims to help support and drive the ASHRAE members in South Africa towards a more sustainable path as an industry. And if we flick to the next slide, you'll see the cover of, that's the cover of the Getting to Zero guideline document. Getting to Zero, I believe we'll post a link to the document in the chat box. But essentially, this is not new research that's been published by us. What we've done is we've tried to compile existing resources that are out there, most notably out of ASHRAE's Advanced Energy Design Guide for small to medium office buildings, some local work done by the CSIR, local work done by Sustainable Energy Africa. We've tried to collate all these resources and make it relevant to the South African market on how do we approach net zero buildings, getting down to a bit of the nuts and bolts. It's a collaborative effort. eThekwini Municipality's Energy Office, instigated the discussions with ASHRAE. Sustainable Energy Africa, the implementing partner for C40 cities, came on board to drive it from their end. And we've also partnered with the Green Building Council of South Africa in conjunction with their net zero rating system, which they currently operate. So those are the parties who've been working on this. In terms of net zero energy, so the guide focuses on operational energy, not embodied energy. And the definition for net zero that's given here by the Green Building Council is a building that's highly energy efficient. That's really important. And then the remaining energy is generated from renewable energy. And that can be preferably on-site, but it can be off-site as well. And that's where the net zero aspect comes in. Just a quick note on the next slide on C40 cities, on the C40 buildings program. Cool. Just a quick note here. So the C40 network is a network of cities, influential cities around the world that are making strong commitments towards climate change and towards cleaner cities. And 28 cities around the world have signed an agreement which basically says that either through legislation or policy, they will drive that all new buildings should be net zero energy by 2030, and all existing buildings, so all buildings, should be net zero energy by 2050. And what many people don't realize is that 4 of our metros in South Africa have signed this agreement. So Johannesburg, Pretoria, eThekwini, and Cape Town have all signed up to this and are driving policy and legislation that's going to require all our new buildings to be net zero energy by 2030. Very relevant to us in the South African context. It's a reality. It's not a nice to have. Okay, so touching on to how do we get there? How do we get to net zero carbon in the South African context? First, I thought I'd talk about a few success factors that come from the ASHRAE Advanced Energy Design Guide for buildings. Number one, I think, is extremely important, is developing culture and mindset in your team for delivering a net zero project. It's that old thing, of visualize, manifest. If your team can see this and believe it, they can create it. But if you've got a team that is reluctantly pursuing this, you're kind of doomed from the start. So really important is to create that culture and mindset around it. And then that team needs to work together. So don't call me up as a developer and say, I need a net zero building. Can you do it for me? Because I can't. And neither can any of the other sustainability consultants out there. It's about having a team deliver this. So every member of the team needs to collaborate to achieving the targets, and it's an iterative process. We'll do concept designs, we'll test them against targets, we'll go back through each stage of the design and refine that. So it has to be collaborative, it has to be iterative. And those targets are really important to set. And the guideline gives some guidance on how to go about setting your targets. But just as you set a financial budget on your projects, energy budgets are really important in this process. Obviously, hiring the right team is really important. And I think it's important to look to people who have experience in this work. But even more important is to look to people who want to deliver net zero buildings. So if you're sitting with people on your professional team who are reluctant and not believing in the concept of a net zero building, you should think about hiring someone that is optimistic and enthusiastic about delivering a net zero building. Obviously, realism, and pragmatism is important, but hire a team that you really believe can do this for you, because it's more important than the technical challenges. The technical challenges can be worked out, but dealing with people is the challenging part of the process in my experience. And then the last 2 items, prioritizing commissioning and educating the occupants, kind of reminds us that it doesn't stop at the end of design. We need to make sure that these systems actually work the way that we intended to. that we've put in our buildings, and we need to make sure that the people use the buildings the way that we want them to. And also, I think something that's not on here is making sure that those people are considered in developing these buildings so that their needs are sort of met from the start, and you don't have unintended consequences. So moving ahead, because I think Marloes is going to kill me if I run past 20 minutes at this point. If there's one thing that I get across today, I think it's this energy hierarchy that's so important. It's efficiency first. It's not possible to take an inefficient building and simply apply technology to get it to net zero energy. If you look at that pyramid, the base of reducing your energy demand is hugely important. And then you look at an efficient technology, and right at the end, once you've pushed things as efficient as you can, then you look to renewables. That's when you look to solar. So the guideline gives some indicative benchmarks to shoot for, but typically in South Africa, an office building wanting to be net zero, you're probably going to need to get to 50 to 70 kilowatt hours a square meter per year. Forget about the technical benchmark, but that's probably about a third of standard practice in the industry today. So you have to focus on efficiency of your building, and you have to be a lot more efficient than how we currently build buildings before we start putting renewable energy on top. The other really important message I'd like to get across is one of thermal comfort and how critical that is. And I think maybe now you understand why ASHRAE, whose concern is heating and cooling and comfort, really, why we are so passionate about this as the ASHRAE SA chapter. If you look at the pie chart there, you'll see that in this case 39%, but often up to 50% of a commercial building's energy consumption goes to heating and cooling, goes to HVAC, heating, ventilation, air conditioning. And why? Why do we do this? Because we want people to be comfortable. And often human comfort, we focus on air temperature, but there are many other factors, as you can see, that affect our thermal comfort. So we need to be able to deliver comfortable buildings with less or no air conditioning. And it's not impossible, guys. I mean, this planet is a place for humans to occupy. We've been occupying this planet for a long time before air conditioning was around. This planet was created to be comfortable for us, and I'll touch on that in a minute. But what it means is we need to look to tools like the ASHRAE 55 Adaptive Comfort Standard, tools that can help us look at more than just set point temperature of air conditioning, but look at how can we design comfortable buildings without air conditioning first, and then add air conditioning when we really, really need it. So that's a really strong message that needs to come across in this net zero discussion. Yeah. Touching on from thermal comfort, one of the tools we use to do this is building simulations. And I mentioned that iterative design process where we kind of work collaboratively, test our results, work collaboratively again. Building simulations, if used correctly, can be the central tool that allows us to test those issues. So it allows us not only to model our energy consumption, but it allows us to test things like shading devices, glazing, natural ventilation. We can test these in order to design buildings that are comfortable without air conditioning first. And then in those times where we can't meet comfort, sure, there may be an air conditioning supplement. So that's the goal here, really. Where, to be honest, at the moment, we design our buildings in such a way that we design them, and then we design the air conditioning to meet whatever that design. And that's something which very few projects in South Africa have have managed to really move into this iterative space of using simulations to inform excellent design. And if we're going to move to net zero, we need to all move in this direction. Also can be useful for daylighting, for glare, not only thermal comfort. So moving ahead, another useful tool. So we've spoken about the ASHRAE 55 standard, and there's a number of other ASHRAE standards out there relating to simulations, relating to thermal comfort. And then we've spoken about simulations and those tools. So the question is, can we achieve buildings that are comfortable in the South African context? Can we achieve these buildings without air conditioning, comfort without air conditioning? And the answer is yes. As I said, this planet, this country was built for human occupation. This is a summary of some research that Dirk Conradi at the CSIR did. But basically, the point we want to get across is this shows the percentage of hours in a year that each of these cities could be comfortable without air conditioning. So you can build a building with passive design, and theoretically in Joburg, Cape Town, for more than 80% of the year, you can be comfortable without active measures, without heating and cooling. And either we need to deal with the 20% through a behavior aspect, or set that expectation, or we look to the most efficient technology to help us through that 20% of the year where we really need heating and cooling. So passive measures is a huge aspect to play, not only technology. So we've now designed a building that's thermally comfortable, as little air conditioning as we possibly need, as little lighting as we possibly need. This is the point where we look to technology. And so, for example, with the heating and cooling, we've designed an efficient building. Now we look at supplementing that small load that we need to meet. And the other thing I've highlighted there is the temperature range is also to look to our behavioral expectations and the client expectations, and maybe allow broader temperature ranges. Or Chilu may speak about maybe certain spaces that can fluctuate more in temperature. These are the kind of strategies that we need to think about to really achieve efficient buildings. Similarly with lighting, we first go through the exercise of maximizing daylight, maximizing, natural light in buildings, and then we apply the most efficient technology. Lastly, we look at plug loads and work with tenants through mechanisms like a green lease, for example, or through fit-out criteria. We can keep the plug loads as low as we can as well. Finally, renewable energy. It's important to understand this up front, but the point I'm trying to get across with this image, if you look at the left image, and I've taken creative license off of a presentation that Jason McLennan does here, actually, from the Living Futures Institute. And the building on the left is a building that's performing at current regulatory performance. So 200 kilowatt hours per square meter per year, office building in Joburg. The blue indicates the amount of solar that building would need to meet its demand. And this is where people start to say that net zero carbon buildings or net zero energy buildings are not possible. But if you look to the right, through efficiency, what's quite achievable is an efficient building, and that one consumes about 80 kilowatt hours a square meter per year. And then you can see that all of a sudden the available roof space starts to match the kind of solar that's required to offset all your consumption. And that's just roof space. Look, this is not 303 battery that Haley was presenting that is maximizing wall space as well. But it starts to give you an idea in planning your renewable energy strategies, why efficiency needs to come first before planning your renewable energy strategies as well. The guide gives a bit of guidance, some good guidance that Sustainable Energy Africa wrote into the guideline around choosing the right people to give you advice on your solar energy installations, as well as some interesting indicative feedback on the feasibility of these installations. And it's not even a discussion around financial feasibility anymore. In fact, our integrated resource plan, South Africa's integrated resource plan, states that solar power is the cheapest way to generate energy. They've limited that over the next while to give coal a just period for transition, which a lot of us are not too happy about. But solar energy is more than affordable. It's the cheapest route to generate power at this point. Okay, so that's really me for this presentation. But in conclusion, just a reminder of a couple of the points we want to get across. The one is that net zero energy buildings are possible, and not only that, are necessary, but we have to drastically push to lower our energy consumption first. We have to push for comfortable buildings that reduce the reliance on energy-intensive air conditioning. And then once we're done with that, the technology's there and ready and affordable, and we can supplement the rest. Cool. Thanks, guys.
Yeah, thanks everyone for attending and for the invite. I think a lot of what Francois and Haley have said, is going to come up in this, but we try to make this in a way that kind of just talks to some of the things that we've learned on this journey. At the moment in South Africa, we've been through this transition where we were looking at Green Star or normal green building certification systems. And now there's quite a lot of interest and talk around net zero projects, and we're already talking about net positive energy buildings. And there's a couple of key things, and Francois touched on it a little bit, is that net positive energy buildings are an example of sustainability leapfrogging. So that means that we are going to almost jump a generation of bad buildings and move from whatever normal is now to these buildings that are almost regenerative. So that's where the leapfrogging aspect comes from. So a little bit about us, Solid Green Consulting. We are based in Johannesburg. We are currently 102 not out, so we have 102 green building certification systems, big 4 of them, including net zero carbon buildings. And as we go through this, you'll notice a consistent theme in what we discuss. And this is a quote that was, I think it's now 3 years ago, the Green Building Conference, when Paul Hawken was the keynote speaker, and he said the first rule of sustainability is to align with natural forces, or at least try to not defy them. And this is a real guiding principle around a lot of the aspects that really have to be harnessed when we are looking at net positive buildings. So within sustainability, there are many different rating tools and rating systems which have got sometimes complicated definitions. Net positive is very easy. Net positive is very easy because all you have to do with net positive buildings is that you have to generate more than you use, which on the surface sounds like it's very simple, but there's one problem, and this is what we define as the energy efficiency gap. Our buildings tend to be quite inefficient, and once you are generating your own power, you're bringing in a limitation, either a financial limitation or a actual physical space limitation in terms of how much you can generate. But it also brings a different sort of mindset to buildings where you have to design according to what you have. At the moment, our buildings are really defined for abundance, for plenty, like we've got an endless source of energy that we're getting it from. And to get an idea of this energy efficiency gap, I think people sort of kind of understand that, yes, maybe the buildings are not that efficient, and how much more efficient than the building that we know do we have to be? So this graph it's indicative. There are no numbers on this because it's just meant to be a visual representation of just how efficient your building needs to be. Net positive or net zero carbon buildings are about energy efficiency. They're not about your eventual offset. if you went through this whole process and eventually didn't do the offset, you would still end up with the most energy efficient building that you've ever worked on. And so this is kind of a comparison between the different types of benchmarks that we have. So you can see that between a Green Star certified building, which is what we are all quite familiar with, or what a lot of people are familiar with, you'll see that we need to be at least 3 to 4 times more efficient than that sort of building. An existing building is 4 to 5 times more efficient. So you can see where the concept of a leapfrog is needed, is because we need quite a significant change in order to be able to make these benchmarks. What we often say to people at the beginning of projects is that if you work on your first net zero or net positive building and something that happens that makes you uncomfortable, if that doesn't happen, then you're probably not on the right track, because everything that's in there has to be things that we've all never done before. A lot of what we'll be talking about now is just the reality of net positive energy buildings as per our experience. It is still fairly limited in comparison to the overall number of buildings. This represents the smallest amount of the work that we have, but it's of course the most challenging and the most interesting. We've got 3 buildings that we're working on that are aiming to be net positive. They're quite different. So one is an office block, one is a residential home in Cape Town, and one is a hotel. And whilst I'm not going to go into detail on these projects in terms of exactly what happened in the design, we'll use these as an example to look at some of the key aspects that are important. So 76 Collett Drive in Johannesburg, this is a project that is pursuing Living Building Challenge Petal certification for energy, water, and beauty. Rugby Road in Cape Town is the first project in Africa to pursue full Living Building Challenge, including net positive energy. And Hotel New in Pretoria, which is actually net zero carbon certified in design and not yet in operation. So they are fully on the journey. And we'll be trying to link some of the learning that we've had so far to these projects and just in general. And there are three key elements, So one is just discussing a little bit around the barriers. The second one is just the high level impact on design, and also the potential. What happens when we remove these barriers and we see that this net positive thing is actually something that is viable and can be done. What happens when the leapfrog is actually occurs. So one of the barriers that we have in South Africa is around legislation. So to be net positive, your power has to go somewhere. So that 5%, we have to feed that excess back into the grid. And the jury is still really out on where this is allowed and whether it's not allowed. And this has kind of been our experience. So in Cape Town, to be a net exporter over an annual period is actually not allowed. That's as far as we've gotten to with Rugby Road. And we are looking at ways that we can speak with the municipalities to see how we can get around that. In Pretoria and in Johannesburg, depending on who you ask, they'll tell you that it is possible, but there's no real clarity on the rules, who can do it, and you are told that it is actually quite difficult. And in fact, in both these places, a lot of times the only people that tell you that you can do it are the ones that say, you can do it, let me apply for you. So it's not information that's common knowledge to people or that's in the public realm. Another interesting aspect of these is, design assumptions. Being a mechanical engineer, and I tend to talk a lot about air conditioning and comfort, but this was an interesting scenario that we were faced with on the Rugby Road project in Cape Town, where part of the energy mix included the electric car. And we had to estimate how much energy needed to be generated to offset the electric car usage. And we looked at various sources of information. And one of the key things that we learned here is that, initial overestimation can actually kill a lot of things. So you have to do research that will lead you to the right place. So initially, the amount of energy that we were looking to offset was based on a standard that was not a local standard, and it equated to an amount of energy that could take an electric car about 60 kilometers a day. And we looked at that in the context of Cape Town, and we said that this means that this is someone who's living in Frederhoek and doing the equivalent of driving to Belleville every single day without fail, Monday to Friday, which really doesn't make sense. And if you take 30-kilometer radius from Frederhoek in Cape Town and you look at where you could possibly end up, it's actually very, very far. We then looked at our own electric vehicle at Solid Green, because we had a Nissan Leaf, and we looked at how many kilometers a day and how much energy we had spent over 3 years of having an electric vehicle, and it was about 20% of what we had estimated. So that sounded a lot more realistic, and that made the actual generation requirements outside of the things that we normally do. It made it make a lot more sense. So once you're trying to account for every single piece of energy within any type of building, there's going to be a lot of this, because you have to make assumptions upfront and see how they carry through. And this is why within the Living Building Challenge, there's a lot of emphasis on data and monitoring your usage, because once you start to see how buildings operate, that's the best input into design, where you can see what actually happened in certain places. So when we're talking about buildings that are 3 to 4 times more energy efficient than before, what are we really looking at in terms of what we need to optimize and reduce? And if we look at buildings over the last sort of 20 to 30 years, there's some aspects of buildings that have just naturally policed themselves. So lights have just become more and more efficient. You can't not get an LED light in a new building. A lot of equipment, Energy Star, people use laptops. A lot of those have generally just been decreasing. Air conditioning, on the other hand, as a technology, has not advanced very far in the last 30 years, because the principles are still the same. The equipment might be slightly different, and there might be slight changes in efficiency, but in general, we cool with air. We've been cooling with air for the last 40 years, even though science tells us that's not the best way to keep a human being comfortable. That, coupled with the way we design buildings nowadays, means that whatever advances has happened in the technology, definitely the design of buildings are such that it really means that the impact of heating and cooling hasn't changed that much over the years. Now, if you've got a net positive target for your building, it means that you've got a budget for how much energy you can have in your building. And this focuses your collaboration around what is really, really important. We very often get asked to do a payback calculation on occupancy sensors, but no one's looking at the elephant in the room, which is the amount of energy that's needed for heating and cooling. So when we go for a more stringent target around building efficiency, it means that you can't ignore where the energy is really going. So if this was an example of a building that you're working on, you could immediately see that where you have to make a significant change is over the heating and cooling. And how can you reduce your energy for heating and cooling by almost half to meet a benchmark? So the biggest design impact for net positive buildings is how many hours a year can your building run without your air conditioning? And it's a little bit different to thinking about it from a natural ventilation perspective, where you say, this is what the climate allows you to do. So if you're working on a building right now and you had to run a simulation and say, if at 12 o'clock, when it's 23 degrees outside, your air conditioning broke, how long would it take before it was 30 degrees inside and you had to evacuate everyone? And that's the biggest design impact. So we're trying to get this going as a metric that we use to evaluate buildings, which is designed without air conditioning, and look at, even if you do have a system, can it be off? Because the only way you can make this type of impact over a building's energy use is by having hours where your air conditioning is off. You know, the best efficiency is off. People often will look at a building and say, well, what technology is in there? And you have to look at what is the actual requirement. So a key takeaway from this would be just that. You know, can you survive in your building without air conditioning, and for how long? So that goes into the topic of aligning with natural forces. You know, so here we're living in Africa, where we know that we have this amazing resource in the sun in terms of just how much energy intensity we get. But the fact that our energy intensity is 40 to 50% higher than anywhere else in the world means that the architecture and the way that we design our buildings has to be suited. And a lot of times the images, if you take a drive around a lot of the sort of central business district areas across almost any city in South Africa, you can see the type of buildings that really they're very climate defiant. They're not suited for where they are, where we know we've got high solar gains, and we have these buildings that are incredibly highly glazed, and we also have buildings which are even more incredibly budget conscious. So all of it comes into a scenario where we are completely defiant with the climate that we have. So this is the first aspect of aligning with natural forces. We need to design for the climate that we are in. And the first one, doesn't matter where you are in Africa, solar intensity is very, very high. So these are two images of the two buildings that have a good example of this. So the one on the left is 76 Corlett. It's a building that it's well shaded. It actually defies a lot of what we would understand around sustainable buildings, in that it's oriented east-west. And what we always say is that there's no real wrong orientation if you provide the mitigation. So if you design your building to account for the fact that it's oriented in a way that's less than ideal, what there is that there are facades that are more difficult to shade than others. So that's why you talk about north-south, because it's very easy to shade those. East-west is difficult to shade, but it's not impossible. The Hotel Neo on the right-hand side is the same. It's a good example of designing for the climate that we have here, protecting the facades against direct sunlight. And then the second aspect of aligning with natural forces is looking at what is the outdoor condition. The bulk of South Africa actually has what we would consider mild climates statistically. So, for example, Johannesburg, the average temperature in Johannesburg is 17 degrees, which means across the whole year, you need heating more than you need cooling. But we always say that it's a cooling-dominated area, and that's only because of the way that we design. So if your building is in a mild climate, you should take advantage of prevailing conditions to run buildings at a minimum just based on what you need for ventilation. And not forgetting that it actually does get cold. Even though we're in Africa, a lot of times we build buildings forgetting that it gets cold. And then when you're in a hot climate, you have to respect the fact that the combination of hot outdoor plus high solar gain means a lot of energy to keep buildings comfortable. So it's even more imperative that you shade the building and you make sure that you design correctly. As much as the climate is not something that we can control, the shading in the building design is definitely something that can be controlled. And this is an example of the inside of the Rugby Road project, where they've got a very interesting roof design that is designed to let south light into the building, and it's completely shaded in terms of direct sunlight into the space. So the next slide is in terms of aligning with natural forces. When you are in a very mild climate and you've got outdoor temperature that is possible for you to cool the building, one of the constraints is that the air conditioning, which is providing cooling, and the ventilation system are often mixing and working together. So if you decouple this, which means you can have your cooling off but have your fresh air working, then that means that you can provide comfort, you can provide a source of cooling without running the big equipment, your compressors and that sort of thing. And that's the 82% in a climate like Johannesburg that Francois was talking about, is that if you can get air from outside into the building reliably for 82% of the time, you won't need your big air conditioning devices. Malus helped me with these slides, and I'm thoroughly impressed with this fresh air fan that's actually rotating. And this is a learning that we had on 78 Corlett, which is the building that we worked on with the same architects that we're trying to implement on 76 Corlett, where you could see that the bulk of the time, the solar loads are being so well controlled that if we could just get air in, but not have to run it through the normal fresh air system, it would actually be comfortable for the bulk of the time. And I think this is something that we all sort of intuitively know, because if you're at your house and you're working, you open the window, and for the bulk of the time, you're not sitting there and it's 35 degrees or whatever the case is. And one of the big factors that people always talk about when we're talking about facades and all of that is single versus double glazing and looking at how it impacts energy. And what we try to describe now and how we try to explain it is that your building fabric is about comfort. So if you can put something in that is going to stop someone from turning on a heater or turning on an aircon, keeping them comfortable, that's where the energy is going to come from. So you can run a simulation that will show you that between single and double glazing, you're not getting enough of a saving to justify the cost, perhaps. But what it does show you is just how much more comfortable, and that's something that you can't do in a simulation model where you account for the fact that the human behavior, that even if you've designed a system for 22 degrees, if your facade has been designed well and it's 24, 25, a person will not need to have air conditioning. And very often, if we look at that aspect in terms of single versus double glazing, looking at it as how much more do you improve comfort, and that has a knock-on effect on energy. We always talk about target-driven design. If you've worked with Solid Green on a project, target-driven design or process-driven design. And one of the key aspects that's always been missing in this whole process is a target that is stringent enough to actually allow the integrated design process. So what we often find is that we do try to run projects through an integrated design process, but if your target is not stringent enough, then it doesn't force the change. So if you say that you want to pass SANS 10400, that's the minimum that you can do, right? So you have to stop your optimization when you hit your target. If you say you want a 30% improvement over SANS, then you stop iterating when you get there. But if you say that before renewables, you want to have a 90% improvement over SANS, then it's going to guide this process, and then you're going to have to do this, and you see the outcome of this. And you'll notice that one of the other key items of the process is that it's only at the end do you look at your energy offset, and that's something that is very important. If you design a net positive building, before your offset of energy, it will cost you less than a normal building, because you just cannot design it the way you always used to design it and have all the aspects of buildings that cost money. You're not going to have the massive glazed facades with the massive air conditioning plants, and that's generally where a lot of cost comes from. If you're designing from first principles, you have to eliminate all of that, and there's a significant cost that is linked to those elements. So outside of your offset, if there are any questions, I haven't looked in the chat. If someone asks how much does a net positive building cost you, before you have the offset, it should save you money. It has to save you money relative to the way that buildings are normally designed. And once we remove some of these barriers and we redefine new normals, we will start to see this change in buildings, and everybody's going to be doing it. With the coronavirus, we've all been talking about herd immunity, and there's also such a thing as herd mentality as well, where once it's done, others will follow in quick succession. The first Green Star rated building was in 2008, 2009, and now there are over 350 buildings, because at the time it was that we couldn't do green buildings, and now green buildings for many people are done pretty much in their sleep. And now we have to look at what the next frontier is. And a lot of the reason why we have to look at the next frontier is that, especially on the African continent, is that there's a lot of benefit for us in making all of this work. We're starting to develop our economies at a time when the climate is extremely constrained. So climate change mitigation a lot of it is falling on us, because we are going to do the most building in the next couple of years. But we also have an issue in that it doesn't matter where on the African continent you go, whether it is in Southern Africa, South Africa, Botswana, Zambia, East Africa, West Africa, there's always a problem of energy generation. There's a need for development, and there are constrained grids across the entire continent. And we are building buildings that require a lot of energy. So it's all very counterintuitive. So if we look at the number of buildings we can currently power and just look at it in relative terms to the fact that we have got this infinite source of energy, the only difference is that we haven't quite figured out how we could design buildings that meet our requirements and also can be powered completely by the sun. And once we do this, it seems like a a weird notion to talk about unlocking the sun, but once we do this, there's really no limit to how we can then develop both sustainably, both in terms of the environment and financially sustainable. And there's a great example, and I apologize for those that came to the first Living Future collaborative, because this is still by far my favorite slide that talks about what happened in the Chilean solar market when they unlocked the sun over there. And I'm not sure if I need to press again or if it has started. I'll press one more time. And it just shows how much solar all of a sudden picked up once they unlocked the sun. So there's this huge potential that we have, and we have it more than anywhere else. And the hindrance at the moment is on our part because we're not designing buildings that are able to harness this. So this is very similar to the slide before, which may have seemed like a little bit of green propaganda, but this is something that has actually happened or is actually happening in a market where they have seen the impact of unlocking the sun. Great, thank you. That's all from me.
Okay, so we wanted to go to the question and answer session. So I'm going to allow some of the questions. I see that there is a lot of questions going on in the chat box, and some of them have been answered. Is there anybody with a burning question for one of the three speakers?
Okay, Chair, will they give me permission to ask the question?
Go for it.
All right, thank you. Through you, Chair, I just want to perhaps address this with Chilu. What we found is that clients would love to go to net zero, but it gets to a point that it just doesn't justify the capex costs to get to net zero. So there's a point where your ROI is justified. It's a journey map towards net zero, but not the full journey through there. But of course, Chilu hinted on where you could invest outside and renewables, etc., outside your premises, and that could be also an offset. Okay, but the challenge we have currently is that the justifying the cost to get to net zero. And I heard also Francois mentioned that the C40 cities. I'm concerned that if it's 2030 that we need to get to net zero, something has to be done now. And here's the issues: who's going to fit the bill, and what is going to be the stimulus package required for companies out there, or even government, to get to net zero?
Yeah, sure. I think there's maybe two or three different answers on that one. So the first one is the cost and the ROIs and everything. They're always based on current consumption, current trends, current behavior. And as we've been talking about now, is that the efficiency is what needs to be different. So we see a lot of, especially clients with portfolios, no one looks at the data, no one understands how inefficient their buildings are. And so if you had a program of saying, we want to be net zero by X, and you started to look at efficiency first, the bulk of people could probably fund their PV from the savings on energy efficiency until they go on. And I think that if you start to look at the beginning on ROIs and all of that on the solar, that's where a lot of projects go wrong. You have to look at the efficiency. If you've got a building that is 20 years old, you've got 20 years of data of seeing how their air conditioning was running. But what normally happens is that after that 20 years, they replace it with the exact same piece of equipment and not using all the other data that they've had before, and maybe putting one that is actually correctly sized and therefore more efficient. So it's definitely a journey. You're never going to walk into someone's office and do a calculation and say, yeah, let's do net zero. I think that especially on existing buildings, there's a very real business case to say, make savings, make money off your portfolio for a couple of years, and then you can fund this thing. So there is a lot of advocacy work that needs to happen in terms of the mindset around why net zero. So even an ROI is something that is a financial aspect that's linked to the fact that, so we're looking at the financial aspect, but we are discussing something around climate change and coming together to see how exactly we can look at climate change mitigation. So it is a very, very difficult thing to deal with clients, and I think it's something that is going to happen over time. If we just get one or two people manage to do this and manage to prove it, then it's all going to work out. So all we need are the early adopters. There are a lot of skeptics, and once you get it to work, then everybody will be on board. As far as government and the fact that the bylaws and all of that coming into play, it is known that it is a very, very stringent thing. And again, if you design your building correctly, it shouldn't cost anyone any money. So the program currently is very ambitious, but I think it's putting in place a lot of things to try and get to that goal by 2030. And what's really the downside if it fails? It just means that we would have had 10 years of trying our best to get to this goal that is significantly better than where we are now.
Okay, thank you. And just maybe in addition to that, Miguel asked as professionals in the built environment, how do we start implementing these principles in the social and lower financial end of the market? Francois, am I putting you on the spot if I give this one to you?
Thanks, Marlies. Yeah, look, I think from a social perspective, we just need to be delivering better buildings. It's similar to that point that Chilu made about we're measuring off our current base case. We need to deliver better buildings. If you deliver a good, comfortable building with low operating costs, then that has a big social impact. You're not externalizing the cost of being comfortable in that home. You're not externalizing it onto a family that has to pay for energy or to burn unhealthy fuel. If we build these buildings in a way that is appropriate to climate and reduce that operating cost and resilience in that it can generate energy from the sun, then that has a huge social impact. So I think this goes far beyond monetary, and at its core, I'd argue that it is social. Developing better buildings is a social initiative.
Okay, I see a lot of hands going up. I'm gonna ask a question for Haley. There was a slide that indicated no combustion at the bottom. What is meant by this? Is Wolfgang is asking.
Yeah, so we really try to remove the use of combustion from buildings, and namely specifically for building scale systems, so things like boilers and stuff like that, whereas the grid is a little bit outside of a project team's control, so but obviously sourcing from renewable whenever possible, but mainly that's just removing any natural gas or other fuel source based building systems, such that we can electrify, and then as all of our grids get cleaner and shift away from fossil fuels, then the impacts of the building energy use also go down. So he's following up about biomass. So that's a very timely question. We have biofuel guidance. Basically, we're pretty strict on that guidance because we want to ensure that any combustion that's happening is we call it beneficial combustion. So basically it's better that you're burning it. And a really good example is that we're working with a waste treatment facility that would otherwise be producing methane, but we're permitting them, they're registered right now, they're not certified yet, but we're in conversations with them for them to combust that methane, which is less impactful than it being released. So when it's combusted, it produces CO2 and water, so that is less impactful than methane, which is about 25 times more potent as a greenhouse gas than CO2. So there's certain circumstances where we permit that, but it is an exception pathway because we really, again, don't want to be burning things when we don't have to be.
Great, thank you. I'm aware of time. We will take note of all the questions and we'll try to answer them in a follow-up meeting on this. Do you want to be part of the collaborative? Drop us an email at this email address, lbc.collaborative.rsa@gmail.com. And yeah, you can find us on LinkedIn and Facebook as well. So with that, I would really like to thank you for your attendance. I see a lot of people enjoyed it, and I am aware of time, so I think we have to close out here, unfortunately. And for next time, we will allow a bit more time for questions. But Thank you, guys. We really appreciate you attending this webinar, and we look forward to the next one.